quadratic relationship has the formula ax squared plus bx plus c, where a, b, and c are coefficients, unknown coefficients that we want to solve for. So if we have this quadratic, it has points at -2, -5, so maybe somewhere around here. -2, -5, 4 over 67, so way up here, and 113, so maybe somewhere around here. Okay, and so it looks like, we might have some parabola that looks something like that. It's hard to tell, but if we have any 3 points on a parabola, we should be able to figure out the shape of this curve. Similarly, if we have 3 points, we should be able to solve for A, B, and C. So since I have 3 unknowns, I need to come up with 3 equations. My 3 equations are going to be based on my 3 coordinates, because if I have an x and y, I can always substitute x and y pair into the equation as an x and y pair. And what that will do is it'll just leave the variables a, b, and c behind. And that will leave me with 3 variables and 3 equations. So my first equation is going to be y equals -5, and x is going to be -2, so I end up with 4a minus 2b plus c. The second equation is going to be y equals 67, x squared is 16a plus 4b plus c. The third equation is when I substitute 1 and 13, so y equals 13. I get a plus b plus c. So there's my 3 equations, my 3 variables. So I'm going to solve this system. It looks like c is going to be the easiest one to get rid of. So I'm going to do equation number 2 minus equation 1. So I end up with 67 equals 16a plus 4b plus c. -5 equals 4a minus 2b plus c. Subtracting these, I end up with positive 72, positive 12a, plus 4 minus negative is going to give me 6b, and then c's cancel out. Again, I'm just going to number that to keep track of my equations. I'm going to combine, let's do 2 minus 3 minus 2, 2 minus 3, so I end up with 67 equals 16a plus 4b plus c, and then I'm going to take away y equals 13, a plus b plus c. So I end up with 54, 15a plus 3b, and the c's cancel out. So I'm going to label that equation 5. And looking at equation 5, 4, and 5, it looks like I can maybe get rid of the b's fairly easily. So I'm going to take equation 4, in fact, I'm going to take half of equation 4 because that's just going to be easier. So I'm going to take half of equation 4, and that will match up my b coefficient. So I end up with 36 equals 6a plus 3b, and then I have my 3b's match up, and I can just subtract this. So this is 1/2 times and the 3b's will cancel out. This is going to end up being -18, -9a, dividing, I'm going to end up with a equals positive 2. Substituting back into one of these equations, maybe I'll substitute into equation 4. Let's do equation 5. I have 54 is equal to 15 times 2 is 30 plus 3b. So 24 is equal to 3b. Looks like b is equal to 8. So my b coefficient is equal to 8. my A coefficient is equal to my A coefficient is equal to 2, B coefficient is equal to 8. I need to solve for the third one. And equation 3 looks like it's going to be the easiest to use. So 13 is equal to A plus B. Oops. A was 2. A plus B plus C. Plugging that in. Solving, I get C is equal to 3. So there are my three coefficients. So the equation of this parabola works out to be y is equal to 2x squared plus 8x plus 3. And if I were to graph that equation, it would fit those 3 points, and I think it's going to look something similar to that.